Elemendar's report annotation tool takes cyber threat intelligence reports and automatically processes them. For example, we can take this report URL and drop it into our API. The machine learning tools that we use are now running on our cloud servers to extract entities and relationships aligned to the STIX taxonomy. Our work in 2022 focused on improving the human-machine pairing aspect of our cyber tool. To achieve this, we recruited a group of analysts from LAS to participate in a cyber wargame, with the objective of improving our tool. Senior analysts from LAS were paired with our project to offer guidance on how best to design the experiments. We asked analysts to use the tool for two tasks: report annotation and situational awareness. For the report annotation task, analysts were presented with the following scenario. The geostrategic situation in Zandir has deteriorated significantly, with strong combat indications that Zandir will stage a military incursion into Zandir. The intent of NATO is to oppose this by force. This has resulted in large-scale troop deployments of military personnel into Zandir. Due to this, there has been a requirement for surge analytical power to support the battle group. As part of being a surge analyst, you are now working as part of the Security Operational Center. A large part of that role is focused on cyber threat intelligence. A large part of your role is processing the open source CTI reports to feed into the wider security operations. Process these documents using read, and then we'll take them away and mark them. The analyst were then asked to annotate a number of reports, some with machine learning predictions and some without. For the second task, the situational awareness, analysts were presented with a number of reports and then asked to answer a series of questions. Some analysts had only the reports for context, whilst other analysts had access to our automatically generated node edge diagrams for context. When both tasks had been completed, we compiled task completion metrics and qualitative feedback from the analyst. Our results confirmed our null hypothesis that machine learning annotations and automatically generated knowledge graphs improved task completion. Examining the feedback further, we found that analyst trust was an important issue. We noted that whilst most analysts trusted the machine's predictions, a significant minority did not, and that impacted the work they did. Here we can see the survey, showing that a majority of analysts trusted the predictions, whilst a minority did not. Our follow-on work package for LAS was designed to improve analysts' trust in automated tools, specifically our cyber report annotation tool. We re-engineered our machine learning codebase to extract confidence scores, and then went through several rounds of design iteration. Our team were able to deliver an updated user face into production. Here we can see a malware with the confidence score attached. Now when you enter a report, you click on an individual entity to find its confidence, with this malware indicating a confidence score of probable. Further down, we can see an indicator has been attached with a confidence score of very likely. Our design research focused on the best way to communicate confidence and what, if any, additional functionality should be included. We designed 3 levels of confidence that were descriptive: probable, very likely, and almost certain. Our work found that this was a much more accessible approach than a percentage. The additional functionality we designed was a confidence filter. For example, this could allow users to ignore all predictions that weren't almost certain. Here I am removing very likely and probable, focusing only on the most certain predictions, where that is a priority for the user. Alternatively, an analyst could use the filter to select only the very likely and probable, thus working through those predictions to correct or accept. The results of our work in 2022 for LAS has been the validation of our machine learning cyber annotation tool. Drawing on the resources available to LAS, we were able to recruit a representative pool of analysts, gather useful feedback, and implement recommended changes to our product. Since the conclusion of Work Package 1 and 2, we have been able to take the improved product to potential customers and ongoing government clients. The feedback has been very positive, as trust in AI is currently a high priority for many organisations. The additional transparency our tool now offers has helped remove some of the black box nature of our AI product. For more information, please see our symposium poster or full work package reports.